Hello YouTube, so this is going to be another video in my series of building a custom computer architecture. So right here you could see this mess of cardboard and soda can thing, and this is actually going to be a pretty important part of my computer because this thing is basically a counter, and that will allow us to work as basically an accumulator as well as like the program counter to count through instructions. So what this thing actually is it's a soda can mounted onto a cardboard thing, and it's covered in foil, but you could see that the foil is blocked off by tape at some points, and that actually gives us the ability to create a binary sequence, and it'll work as a counter. And right now this is connected to positive, so this wire is the axle, and this goes straight to this can, which is covered in foil, connecting it electrically to this axle. And then these paper clips work as brushes, and they brush up against the foil and a number is displayed. So if you see right here on these LEDs actually display the number that is currently being shown on the count. It's not exactly tight. What I actually have to do is I have this kind of sprung against the back with duct tape. I need to use like rubber bands or something to actually make the contact better. And also these paper clips aren't exactly even, so the numbers don't go at the same time, but in principle it does work. So let's just go to reset at 0. So as you can see, it's covered in tape, so it's 0. And then 1, you can see it's 1, 2, 3, 4, 5, 5. Yeah, that one's a little off. 6, 7. There we go, 7. 8, 9, 10, 11, 12, 13, 14, and finally 15. And as it keeps turning, it will reset to 0. So what this allows us to do is several things. First, we could hook up a motor to this, and it could be used as a counter. And this is very important to be able to step through instructions. And yes, you could implement this function with transistors, though I have been having a hard time doing that, so that's why I just decided to go with this sort of 19th century design right here. And it should work. Of course, the objective is not to make a fast computer, it's not to make a good computer, but to make something which could be described as a computer. And I believe that this device will fit that purpose as it is. So, for example, this could step through instructions, and this could be the current address in ROM. And then it'll go to address 1, address 2, address 3, address 4. And then, for example, we could have a jump instruction, and that could say, okay, go back. And reversing the can is not really good because the paper clips they're pointed up. So what it could do is it could just cycle back through, and if we want to go to address 1 again, then we'll go back, and then we're back at 1. So that's how like a conditional jump could work if this is the program counter register. Uh, Also, this works as a storage device just as well. For example, if we want to store the number 5, we could go, okay, just keep moving it until we reach the number 5, and we have right here. So we have this number 5, and this will keep stored in here. And this is a non-volatile storage. So this is basically a read and writable memory that is completely non-volatile, because unless you move the can, the number that's currently stored is the same. So that's also quite useful as well. And for this, I don't actually want to use this specific thing on my computer just because it's made out of cardboard and it's not very durable, and as you can see, it's kind of hard to actually get the number to display because it doesn't press down as well. But what I will probably do is I will 3D print a mechanism pretty much like this. I'll probably still use paper clips, but they will be sprung back against the mechanism with rubber bands, and they will also be lined up more properly. So I think that will be a very good solution for a 4-bit architecture to step through instructions, jump between instructions, and also have a means of non-volatile storage. Of course, this is all necessary because I've been having a lot of trouble making a flip-flop with BJT transistors. Here's one of my attempts right here. This mess right here, it does not work. I don't know why it does not work, but I suspect it has to do with the fact that BJT transistors consume current, so that makes the architecture harder than if I would just use MOSFETs. 1-bit D flip-flop, and it doesn't work. I need 4 bits, so that's 4 of these. If I made them out of MOSFETs, that would be pretty expensive. I think that just making a bunch of these might be a better option. Even though this does need a motor on it to actually spin it, so that might be a bit expensive to make, but I know this does work though, which is a point in its favor. Also, it's just an interesting mechanism requiring really no computer parts. It's just this is just basically a rotary switch. It is like a 4-throw rotary switch. I think that's what it is, and it's an interesting concept, and I'm glad that I could share it with you today. Thank you for watching.